So, in last class I have solved a problem on bearing capacity of or the load carrying capacity of pile in homogeneous sand, and I have solved that problem by using 3 different methods, and then considering I have solved the problem considering critical depth or critical length concept and without considering the critical length or critical depth concept. Now, in this class I will solve a problem on layered soil. Okay. So, the problem is that we have a, so this is the layered soil, and soil layer, this is ground surface GL. This is the first layer of 4 meter, this is 0 meter. Then the second layer is 5 meter, that means up minus 9 meter, and then the pile is inserted here. So, total length of the pile is 14 meter. Okay. So, the pile base is at minus 14 meter. So, total length of the pile is, so this is minus 14. So, this is 4 meter plus 5 meter plus 5 meter, okay, is 14 meter. And this diameter of the pile is taken as 350 millimeter, and water table is at 2 meter below the ground level. So, this is this soil is loose sand, and the gamma value is given 17 kilonewton per meter cube. The second layer is medium sand. This is the medium sand, and unit weight is taken as 18 kilonewton per meter cube. Phi dash is 34 degree for the second layer, and phi dash is 30 degree for the first layer. And for the second layer, third layer, this is dense sand, and unit weight is 20 kilonewton per meter cube, and phi dash is equal to 39 degree. Okay. So, now we have to solve this problem. So, now from the table we have taken for the loose sand for the concrete pile, and this is also driven pile. Okay. This is also driven pile. So, K value is taken as 1, delta value for the concrete pile is 0.755. So, that is equal to 22.5 degree. For the second layer, K is taken as, it is medium sand, because K value is 1 for loose sand and 2 for dense sand. So, medium sand I am taking, it is 1.5, delta value is again 0.75 of phi. So, that is equal to 25.5, and dense sand K value I am taking 2 and delta value again 0.75 of phi, and that is equal to 29.25 degree. Okay. So, now the phi value is equal to 40 degree, L by D is equal to, this is the 14 divided by 0.35, and that is equal to 40. So, from the chart NQ value is equal to 132. So, one thing I want to mention that in few researchers
they have suggested that you take the length of the last layer where it is penetrated, and this last layer length, that means 5 meter when you calculate the L by D part. But I would recommend to take the total length of the pile and the diameter at 0.35 and take the phi value of the layer where the pile is rested. Okay. So, phi value I have taken of that layer where it is it is 39 degrees, sorry. So, it is 39 degree where it is rested. So, that 39 degree I am taken, and the L by D value is taking the total length of the pile. Okay. Total length of the pile when you are talking about the L by D, and the phi value where the tip is rested. Okay. So, that is the layer where tip is rested or pile base is rested. So, that phi dash is taken 39 degree. So, now this phi value is 132, or it can be around, because I am taking from this chart. So, it will be around 132, 132. So, I have taken 132. So, now the sigma bar. So, this is I am solving without considering critical length. Okay. So, the sigma bar, I am taking the full effective overburden pressure. So, sigma bar will be 2 into 17 for the top part above the water table, then again 2 into 17 minus 10, then plus 5 into 18 minus 10, then plus 5 into 20 minus 10. So, that is equal to 138 kilonewton per meter square. So, my Q P U is equal to sigma bar into N Q. So, N Q is 133 from the figure. So, how? So, we are using the first method, and on all other problems I will use the first method, and I will prefer to use that method. So, in the remaining problems I will use the first method, and I will use that chart to calculate the NQ. So, this is the NQ from the chart. So, and this value. So, that means the chart, I can show you the chart that I have considered. So, I have used this chart basically. So, this is the chart, it is 39 corresponding to L by D 40. So, this will be the value 132. So, now this is the sigma bar NQ. So, NQ is 132. So, sigma bar 138 into 132. So, this will be equal to 18216 kilonewton per meter square. So, I will take the full stress. So, that way I will not reduce this value. So, that means Q P U is equal to pi d square by 4 into 18216, that is equal to 1752 kilonewton. Okay. So, that is the QPU. So, next part I will calculate the friction resistance, that is the FS1. So, that I will calculate from 0 to 2 meter. So, now if I draw the stress distribution, so up to 2 meter, this is the value, then it will further reduce, then it will further increase, then this is the stress distribution. So, I am giving you the values. So, this is plus 2 meter, this is minus 2 meter, this is minus 4 meter, this is minus 9 meter, this is minus 14 meter. Okay. So, 14 meter I have already calculated, that is 138 kilonewton per
meter square. For 2 meter, it is 17 into 2, that is equal to 34 kilonewton per meter square. And the 4 meter, that will be that 17 into 2 plus 2 into 17 minus 10. So, that is equal to 48 kilonewton per meter square. So, similarly, here it is 88 kilonewton per meter square. So, if I calculate the first part, then this will be the average value 0 plus 34, k is taken 1 and tan it is 22.5 degree. So, that is coming out to be 7 kilonewton per meter square. Fs2 from 2 meter to 4 meter, this value is the average of 34 plus 48, then k value is 1 and tan 22.5 degree. So, that is equal to 17 kilonewton per meter square. Then Fs3 from 4 meter to 9 meter. So, this is also half 48 plus 88 average, k value is here is 1.5, because this is the second layer, 4 to 9 is the second layer where k value is 1.5, and 0 to 2 and 2 to 4 is the first layer where k value is 1. Okay. So, 1.5 and here the delta value is 25.5. So, we will take into tan 25.5 degree. So, the value is 48.7 kilonewton per meter square. Then Fs4, which is 9 meter to 14 meter, and this is half into 88 plus 138 into 2. Here the k value is 2, delta value is 29.25 into 2 into 10, 29.25, and that is equal to 126.6 kilonewton per meter square. So, my QF is equal to pi d is 0.35. Then we have to consider this length. The first one is 7 and the length is 2 meter. Then second one is 17, length is 2 meter, 4 minus 2, that is 2 meter. Third one is 48.7, length is 9 minus 4, that means 5 meter. Then the last one is 126.6 and the length is 14 minus 9, again 5 meter. So, this is equal to 1016 kilonewton. Okay. So, the value is 1016 kilonewton, and ultimate value will be equal to, that is 1752 plus 1016. So, that is equal to 2768 kilonewton. So, the Q safe is equal to 2768 divided by 2.5, that is equal to 1107 kilonewton. So, this is the safe load without considering the critical length concept. Okay. So, now I will consider the critical length concept for the same problem, and then we will see how much difference will be there. The same problem, if I consider the critical length. So, the same, this is the ground level. So, now considering Okay. So, same ground level is 0 meter, this is minus 2 meter, where it is the water table, this is the ground level, this is the water table, and here this is 4 meter the first layer, this is minus 9 meter the second layer, and minus 14 meter third layer. Up to 14 meter this pile is resting. So, the distribution will be, now if I draw the stress distribution. So, now the question is which critical length we will consider, because this first layer is the loose sand, second layer is the medium sand, third layer is the dense sand, and so I would prefer to take the critical length as a critical length divided by d is 15, because that is the range from loose to medium, and for the dense sand it is 20, but the soil the top portion is loose to medium. So, I will take that critical length divided by d is 15, okay, because that is the top portion where this is the loose sand, this is the medium sand. So, if I take this is 15. So, your critical length is 15 into 0.35. So, that is equal to 5.25. Okay. So, that is the critical length. So, again if I draw the distribution. So, up to 2 meter this is the value. So, up to 2 meter it will be 17 into 2. So, that is 34 kilonewton per meter square. Then 4 meter, again this value is 48 kilonewton per meter square, because in the 4 meter we have calculated, that is 48 kilonewton per meter square. Then the critical depth is up to 5.25. So, it will further increase up to 5.25. So, this is minus 2, this is minus 4, this is minus 5.25. Okay. So, this value is 5.25. So, this value is 58 kilonewton per meter square. Then after that it will remain constant, okay, because we are considering the critical depth concept. So, this is minus 14 meter, and in between that here it is minus 9 meter. Okay. So, this is 58 kilonewton per meter square, this is also 58 kilonewton per meter square. Okay. So, now first we will calculate the QUP, QPU. So, QPU that NQ will remain same. So, sigma V into NQ, and NQ value is 132 we have used in the last problem, that means sigma bar is 58 and NQ is 132. Okay. So, this is 7, 6, 5, 6 kilonewton per meter square. Okay. So, now QPU is equal to pi 0.35 pi d square by 4 into 7, 6, 5, 6, that is equal to 736 kilonewton. Okay. So, now I will calculate the friction part. So, first the skin friction. So, first FS1 that I am calculating from 0 to 2 meter, 0 to 2 meter, which is again half into 0 plus 34, k value is for this portion, that will not change. So, k value is 1, delta is 22.5, here k value is 1.5, delta is 25.5, here k value is 2 and delta is 29.25. So, your k value is 1 and this is tan 22.5 degree. So, this value is coming out to be 7.04 kilonewton per meter square. Okay. So, similarly, the Fs2 will be the average of these two, that is 34 plus 48 and here it is 1, k value is 1 and tan is 22.5 degree. So, that value is, that is Fs2 is 2 meter to 4 meter. So, that value is coming out to be 40. So, this is your 22 and so the final value, I have the final value. So, this is the calculation. So, similarly, from here I can calculate Fs1 is equal to Fs1 into As. Okay. This is the QF1 As. So, As is pi into 0.35 and Fs1 is 7.04. So, this is equal to 15.5 kilonewton. Okay. Similarly, QF2 is Fs2 into pi d and there will be L also. This is 2, L is 2, because this is the pi d and L is 2 meter, because this is 0 to 2 meter into the Fs, this is 7.04 and Fs2 into As, that is pi into 0.35 pi d and L is 4 minus 2 and then into Fs, Fs is equal to, this value is, this Fs value is half 34 plus 48, k value is equal to 1 into tan 22.5 degree. So, that is equal to 37.3 kilonewton. So, here I am just directly calculating the Q. In the previous problem, at the end of the all calculation of Fs, I determine the Qf. Here I am separately calculating the Qf. So, similarly, the Fs3, that is from 4 meter to 5.25 meter. So, that is equal to 4 meter to 5.25 meter and here the this value is 48 and 58. So, 48 plus 58 and here this k value is taken as 1.5 and tan value is taken as 25.5. So, now if I calculate QF3, so that is pi d, L is here minus 5.25 minus 4 into this value. So, into half 48 plus 58 into 1.5 into tan 25.5 degree. So, that is 57 kilonewton. Okay. Similarly, I can write the QF4, that is from 5.25 to because the 5.25 to 9, because although the stress is uniform, but up to 9 there is one layer and beyond 9 there is another layer. So, we have to consider up to 9. So, this is up to 9 meter. So, the value is pi d 0.35, L is 9 minus 5.25, then this value is uniform value, because 58 is throughout this uniform. So, that stress is 58, and then k value is taken is k value is taken as 1.5. So, that is 58 and k value is here, k value is 1.5 and delta is 25.5. So, k value is 1.5 and delta value is tan 25.5 degree. So, this is 171 kilonewton. Okay. So, next one Q F 5, which is from 9 meter to 14 meter, that is equal to again pi d, L is 14 minus 9 into again uniform 58, but k value is 2 here, k value is 2 here and delta is 29.25 and delta is tan 29.25. So, that is equal to, this value is coming out to be 357 kilonewton. Okay. So, now the final Q F is equal to 15.5, 37.3, 57, 171 and 357. So, I can add this 15.5 plus 37.3 plus 57 plus 171 plus 357, that is equal to, this value is equal to 3638 kilonewton. Okay. So, now Q u will be equal to 736, because this is 736 plus 638. So, that is equal to 1374 kilonewton and Q safe is 1374 divided by 2.5, that is equal to 550 kilonewton. So, this is the load that pile can take when if I consider the unit critical depth, and this is the load pile can take if I do not consider the critical depth concept. So, in the next part that I will start is I have solved the problem of pile in the mainly in the granular soil. So, and I have solved this problem for homogeneous sand as well as layered soil. So, in the next part I will start the load carrying capacity of pile in clayey soil. If the pile is in clay, then what would be the load carrying capacity. So, these things I have discussed, I have finished that. So, now pile is in clay. So, the same thing here also pile will get the resistance from the tip as well as the friction, but here the equation is slightly different, that here. So, as the phi value is 0. So, the n gamma value will be 0, n q value will be 1. So, that part we have neglected here. So, we have considered only q n c, c u n c and the friction part. So, that means here here it is the tip resistance and this is the friction. Okay. So, friction is alpha is the adhesion factor. So, generally this N c value is taken as 9, C u value is the undrained cohesion, A b is the area of the base and alpha is the adhesion factor. So, how will and C is the cohesion, A is the area of surface area of the pile. Now, how I will calculate the adhesion factor? So, I will get the adhesion factor from this table, that if the soil is soft to very soft, then the driven pile it is 1, medium it is 0.7, steep it is 0.4, steep to hard it is 0.3, and which based on the Cu value also we can identify which soil is soft, very soft, medium, steep, very steep and hard. And we have a graph also, from here also we will get the value of the adhesion factor if I know the cohesion value. So, in the next class I will solve the problem on pile in clay, and then I will also discuss the IS code recommendation, was IS code has mentioned how to calculate the load carrying capacity of the pile in clay. Thank you.